SS7 and SIGTRAN are protocols that were designed to carry over the signaling information of voice calls. For a call to be made, signaling information has to be carried over the network, along with the audio, to provide directions for the call to reach its destination, whether it is a carrier or a receiving endpoint. So, the SS7 and SIGTRAN protocols were created to allow this information to be carried over without competing for space or available voice channels. In other words, an additional path was created to carry over the call signaling information. There are three basic network elements in the SS7 architecture: the SSP, the STP, and the SCP. The service switching points are the telephone switches that are interconnected to each other by SS7 links. The SSPs performs call processing on calls that originate tandem or terminate at that site. The signal transfer points are routers that relay messages between network switches and databases. Their main function is to route SS7 messages to the correct outgoing signaling link, based on information contained in the SS7 message address fields. The service control points contains centralized network databases for providing enhanced services. Example of services include toll-free numbers and prepaid subscription. The Common Channel Signaling System, or Signaling System number 7, is a set of protocols designed to enable telephony networks to exchange information, so that calls can be made between telephones and be charged correctly in a transparent manner. In other words, SS7 is directly responsible for interconnecting telephones and telephone exchange with each other. Because SS7 is basically a network that is integrated into the existing telecommunications network, some began to wonder if it would be possible to use an Internet Protocol network instead, replacing the traditional 64 kbit signaling links. As a result of this, SIGTRAN was created. There are three basic elements in the SIGTRAN network configuration. There is the media gateway, the media gateway controller, and the signaling gateway. The media gateway terminates voice calls on either switch trunks from the PSTN, compresses and packetizes the voice data and delivers voice packets to the IP network. For ISDN calls from the PSTN, Q931 signaling information is transported from the MGW to the media gateway controller for call processing. The media gateway controller handles the registration and management of resources at the media gateways, and media gateway controllers exchange ISP messages to its CO switches via signaling gateway, sometimes called a sub-switch. The signaling gateway provides transparent interworking of signaling between switch circuit and IP networks. The signaling gateway may terminate SS7 signaling or translate and relay messages over an IP network to a media gateway controller or another signaling gateway. SIGTRAN is a group that pertains to the IATF and is dedicated to studying signaling information transport over IP networks. It has developed a family of protocols that provide a more reliable service for the SS7, being actually an extension of the SS7 family protocols. SIGTRAN handles the same applications and call management functions performed by the SS7. However, SIGTRAN uses the IP and SCTP protocols instead of TCP or UDP, mainly due to security issues. SCTP is responsible for carrying the PSTN signaling information over the IP and for the reliable transfer of messages between its users. The way SIGTRAN works is that essentially refers to an entity called media gateway. The media gateway works as an interface between different media formats across public and data networks, and it also connects the public analog network to a network of data packets.